there. So we are starting with the X space, Twitter space. So you see, Chainaware is the host, but it's actually Martin is here behind here. Okay, let's wait till our co-founder Tarmo is joining too, and then I will give him the permissions to speak, and then we can start today with a very exciting topic. Maybe it will be a little bit more theoretical. Now, Tarmo, you have to send a request. Okay, I received it. Okay, I will approve request to speak. Now, Tarmo, can you speak? I see that Tarmo, you are a listener. Interesting. Okay, Tarmo, can you send one more request? Somehow I approved it, but somehow it disappeared. Let's try one more time. Okay, request sent. Just waiting for the request, Tarmo. You have to send a request. Okay, Tarmo is rejoining. Okay, let's wait a little bit. Okay, now Tarmo joined again. Approve. Okay, Tarmo, can you hear me? I can hear you, Tarmo. Tarmo? Oh, very good. Okay. Now, don't press any buttons anywhere, so let's start. So, okay, guys. Today is then the X space, the Twitter space number 13. So we are doing the X spaces every 2 weeks, and we're speaking about AI and Web3. Now, today's topic is more about AGI. Then, okay, we are speaking a lot on AI, child AI, and so. Okay, Tarmo, you're scrolling in the background. Oh, yeah, I can hear it. Then we are speaking about the general AI and the Web3, but today then we focus on AGI, and later we look as well on the Web3 then the relation of the Web3 in this game. Now, but before we are starting, let's do an intro for the people who do not know us. So we are the co-founders of Chainaware and of Smart Credit, but let's do it so. Tarmo, would you like to start with your intro? Then I will do my intro, and then we introduce the product, and then we get into the discussion. So
yes, hello everybody. I'm Tarmo. I'm distinguished architect. I've been in architecture profession some 25 years. I am ex-chief architect of largest Swiss banking platform. I have 11 years architecture experience in Credit Suisse, etc., etc. Built over 200 applications. And 1 PhD, 4 masters, PhD by Nobel Prize winner, CFA, Kaya, everything, whatever you dream is my background. Martin, back to you.
Yeah, Tarmo has 4 master degrees and then 1 PhD. Now I have only 4 master degrees. Okay, we got all of them from the different universities, but it doesn't mean that we're theoretical persons. We're very practical persons. Now, myself, I worked before then as well as Credit Suisse 10 years in Zurich. Now, before this, I'm coming from the startup sector. I launched 4 products with more than 250,000 users. Now, probably more than 350,000, or maybe even more users. And we launched before as well as Smart Credit. It's a top 20 Web3 DeFi borrow lend platform, and it's the first fixed interest borrow lend platform. And then we have a Chainaware. That's the second product. Okay, now Smart Credit key focus is on the self-custodial banking with a special focus then on the fixed interest. So it's a DeFi product. And then it's a Chainaware. Now a big jump from DeFi into the AI. Okay, we started first with the credit score, which we did with the AI. We launched it in 2021, 3 years ago. We launched the AI-based credit score. And then we started to add other products in a Chainaware. Tarmo, would you like to say more about other Chainaware products?
Yes. We have very strong predictive AI. We can predict fraud when fraud will happen with one of your account partners in future. We can predict if a contract will make a rug pull. If you have some pool in Uniswap or PancakeSwap, we can predict if rug pull will happen. So we know very well what are capabilities of machine learning, AI, or optimization techniques, and we offer it for all crypto community to increase trust and yeah, to get the
Okay,
crypto.
yeah, okay, because the fraud detection and rug pull detection, it's a predictive, so we find them before it happens. We are not like others who are finding it after it happens. No, we find it before it happens, meaning these are the addresses or these are the contracts who will then commit, let's say, fraud or the rug pull in the future. So we say better do not interact with them. So it's not self-fulfilling prophecy. It's rather backtested. So we are 98% a backtesting algo, backtesting prediction accuracy, and we have been using very widely the AI prediction models. So predictive AI. I can hear some typing. Someone is typing.
Martin, sorry, it's rain outside. There's nothing I can do.
Oh, I wasn't aware of this. Oh, okay. So that's practically predictive AI, and yeah, that's general. Now, but let's get now to the topic today. The topic today is an AGI. It might be, maybe it gets a little bit theoretical, this topic, but let's fall through. So stay with us. So because we will look on the LLM. Okay, yeah, okay. In China, we are doing a lot of predictive AI. Okay, we are not doing LLM, and we are speaking on AGI and LLM relations and what are the steps required to get to the AGI, and is an AGI really then appearing very, very fast, or is it just something which takes quite some time? So, that is happening. So, yeah, let's get started. And we are keeping the discussion on 1 hour, so that not overstretch. So 60 minutes only, and then we by 60 minutes then we start to close the discussion. So let's get started. So, yeah, Tarmo, how would you classify what is LLM, what is an AGI? Let's establish first the terms.
Yes. Let's start with LLM. And there is so much buzz about LLMs. What are large language models? They just predict you the next probable word. It is just a prediction of the next probable word. And what happens is we think it is a kind of intelligence. Yes, it has been trained with all public available data, and in public available data, it can predict the next word, what comes after word, first word, what is the second word, and we think it's intelligence. No, it is not intelligence. It is something what is called like you just speak, you don't know what you speak, you just add words after words after words. These are LLMs. And what is crucial by LLMs, if you ask LLM, why did he respond, how it responded, LLMs can't explain. LLMs can't explain why they respond like they respond. And it's not a reflection. So maybe Martin, I bring this example of this famous question, but the LLMs really struggle. And you can, everybody, add it to your chats or ask LLMs and ask the question. It's now, if Alice has 4 brothers and 2 sisters, how many sisters do Alice's brothers have?
And that's what LLM is then getting a little bit stuck. Yeah.
Yes, it's getting stuck, Martin. It's getting just stuck. It cannot respond, and there is very interesting things happen. It starts somehow lying, or it starts somehow answering something, and then you ask, why do you think like this? It cannot, of course, explain, but he still tries to answer you. But the key is he cannot answer this question. And this characterizes LLMs. And when there is kind of if people tell you that LLM is intelligence and lead us to AGI, then there is probably some gap in reflection, Martin.
Okay, yeah, yes, LLMs are autoregressive models. So that we are asking a prompt, we're asking a question, and now the most probable sequence of words after this prompt is found. Now, but finding this most probable sequence of words, it doesn't mean that the algorithm who is finding them understands what he's finding. He's just giving you the most statistically viable answer to this question. So it's a statistical function, but it's not understanding what he's doing. That means there's no logical thinking behind. Now, let's take a chess. We are playing chess, so we are playing some other thinking game, so there has no logical thinking. So in LLM, there is no logical thinking. There is just...
Martin, maybe it's just a bad thought, but maybe people call LLMs intelligence because they don't think in so-called level 2 thinking, where they think really like you think in chess or strategy games, and they don't know what is level 2 thinking, and then they think that level 1 thinking, what LLMs do, is intelligence. And it can be even like this, Martin, that we have forgot what is level 2 thinking. And yeah.
So that means what we're saying, like we have now this huge wave of the AI that is very much driven by the open AI, the LLM models, and there is of course a huge hardware infrastructure behind to it's required then to train the LLMs. LLMs will lead the training. There is then runtime as well, runtime hardware to answer the LLM the questions that you are asking for the LLM. But just that we have to say now. The topic is an AGI today, so is LLM AGI? So Tarmo, how would you say it?
It is maybe part of AGI, but AGI has all thoughts, Martin, are available. All technologies that we need to build AGI are available, of course, outside blockchain. It has nothing to do with blockchain. If people think there is AGI in blockchain, no, there is no AGI in blockchain, and it's impossible. And technologies that we need to build AGI are available. And what is very interesting nowadays is that everything is pushed towards LLM. It's like the main narrative. With LLMs, you can build AGI. And it's good for NVIDIA, it's good for Microsoft. But the point is to build AGI, you don't need this huge compute power, Martin. The best example is these experiments which were now done with Llama 8P model, and Llama 8P model was combined. It's a very small model. It's 2,000 or 1,000 times smaller than you take commercial mainstream models. And with this model, when it was combined with some graph optimization, it could solve mathematical questions that LLMs couldn't solve, other big LLMs. And it was example that you combine different concepts. You combine graph optimization with a very simple, very small LLM, and you get better performance in mathematics than you have it by OpenAI 4G models and other Gemini models, etc. And this is very, very interesting. It shows you don't have now to optimize this one concept, what is LLM. You don't have to build these huge compute centers, but everybody tells you, oh, we built biggest compute center, we invest 7 trillion, or I don't know how many USDs, and then we have it. No, this is investors misleading, and it's misleading of community. The answer for LLMs or AGI is more if you combine existing concepts. But Martin, before we
let's speak a little bit more of the LLM. Like, what are the limitations of the LLM? So we say the LLM is just generating the words, the sequence of the words, autoregression, the most probable words. Now, without understanding what this actually means. So he's just saying statistically, this is the most probable answer. After analyzing now all public data that is available, Now, what else? What else can you say about LLMs?
It cannot explain why it answered like it answered, and there is no reflection. And now imagine you write an essay. You make a first round, then you reflect, you make a second round, third round, fourth round, and then you have beautiful language and you have ideas, you have concepts which reference each other. It becomes really amazing. And this is what LLMs don't do. LLMs answer you just answer, but there is no like reflection. And if you want this reflection, then you have to take now the answer of LLM, send it back to LLM and tell her or him, now please reflect, let's say you wrote, can you do it better? And so you have to do this sequential thinking like yourself, and LLM now again. And this is like LLM is just it does do something, it predicts you the next words, but no reflection, no iterativity. And the big
No, no
question is,
logical thinking. Let me make an
yeah.
example. Like, what does it mean that LLM does not know why he's saying this? Let me explain. Now, let's imagine again a chess. If you're playing a chess, like say, okay, some players are thinking in advance, more moves, some are less moves, thinking in advance, but you know why you're doing a certain move. You have a certain strategy that you
Mhm.
try to implement, and you can reason, you can explain to others now. If others are asking why you are playing this sequence of the moves, then you have a certain strategy, you can explain the sequence of the moves, what you try to achieve. And of course, your opponent is then trying to achieve something different. So, but you can explain it now. And this feature that we are logically thinking and we can explain why we got to this conclusion. Now, this is not there in the LLMs now. And
Why?
if people are now,
Yes,
say again,
why?
Tom.
Why did I answer like I answered? Explain me it. This is missing in LLMs. This is why.
Mhm. So you get just a sequence of the words, and now, and this now is the sequence of the words an AI. Or, well, it can be classified as an AI. Okay, but it's not AGI. It's not intellect, because in the case of intellect, let's take again a chess play, chess or the Go game. So we have a logical explanation. So there was a lot of possibilities. There was a lot of possible moves on the chessboard, but I chose certain strategy that I did. So why did I choose this strategy? What was the reasoning? And that's why we're getting to the AGI. AGI can reason, can explain why he's doing a certain decisions versus the LLM, where we are just getting just a flat sequence of the words. Now,
Mhm.
and of course, this is called AI. Now, the LLM, well, it can be AI. AI algorithms are used in LLM production. Yes, that's true. Yeah. But this is the limitation of the LLM. So, Tarmo, you're calling it as well like level one thinking. Do you want to say what is level one thinking?
A level 1 thinking is you have something in your subconsciousness programmed, whoever programmed it, and you just respond a question. You don't know why. You just respond something. You give answer. You cannot explain why you answered. It's like this. It's your subconscious thinking, and it's just has also information in your subconsciousness, and based on this information, it generates a response. But you cannot explain why you answered this question like this, and you answer and then you think, oh, why did I answer it like this? Oh, I don't know, you have been programmed, like in your subconsciousness has been programmed. And this is what we have in LLM today. LLMs are like level 1 thinking. It answers your questions, it answers your prompts, but why? I don't know, nobody knows. It's just probable answer. And this brings us now to the point of accuracy. When we have predictive models like we have it in Chainaware or Smart Credit, we can exactly say our models give you 98 or 99 or how many percentage exact and accurate answer. We have exact statistics. And now take LLM. If LLM cannot tell you explain you how he answered the question, what is the accuracy of this question? There is the concept of accuracy is missing. I can I can just generate a sequence of words, and there is no need for accuracy. And one thing is this level one thing, and the second is accuracy of these answers. And what happens now in industry, Martin, is that more and more companies recognize that answers from LLMs are really often you can't forward them to customers.
Exactly. Yes. It started with the ChatGPT, but now some companies are realizing you cannot use it as a ChatGPT. Yes.
Yeah, and what is industry doing? Oh, to say, oh, we have to build even bigger compute clusters.
Bigger models, more
we
compute.
have to bring bigger models. Oh, we need even more data. But this is now who benefits? Benefits NVIDIA and hardware producers, they benefits. But Martin, maybe now it's time to go over what is really needed for AGI, or what are these pieces that we have to connect for AGI, or please, Martin.
Exactly. Let's make an example of this chess game. Now you are playing a chess. Okay, we know the deep mind, AlphaGo, and these things, their algorithms. But let's just imagine the chess game. Now that means you are making certain moves. You know why they are making these moves. Your opponent is reacting, and you are making certain moves then to win the game. So that means you have a certain decision tree. You have a lot of options. You are making decisions. You have some search space, and in this search space, you are searching the most best, let's say, the outcome. Okay, in case of the chess or in case of Go, it's easy because the outcome is you are winning the game. So it's easy now. If you're getting human interactions, then your language, and language is not always so exact as a chess game or mathematics or the Go game. But you have a certain decision tree, and you can make a lot of decisions, actually decision paths. And some of these decision paths are then better than the others. So, and that means there's some logical reasoning why you are making a certain decision path, because then let's take humanistic thinking that this decision path is then better than the other. It's getting then more benefit.
And you can explain it, Martin. You can explain why you choose the following move and not this other move. You can explain it in this all decision tree or decision graph. You can give a reason and explain it. This is because of. And sorry, I came in. I just wanted to add it. Yeah.
So, and that means we are getting the logical thinking. We are getting a logical thinking. We are getting search trees. Okay, let's say decision space, and through this decision space, we are then searching the best multi-step, what is called multi-step sequence, which is giving you the best outcome. Let's think again. Let's visualize against the chess game and making multiple moves. Okay, with the purpose to win. So, and on every step, I have let's say pretty many possible combinations that I can do. But some of these combinations are better. So that means we are iterating through the search space in case of intellect, and we are trying to find the best. Now the best outcome. So and not only that, we are trying to find the best outcome. We are trying to create new combinations. We are trying to synthesize something new, which will then give the best outcomes. So we have a search, and we have synthesizers. Now, the synthesizers is not what LLMs are creating, that we are creating the sequence of the words without understanding it. There is a synthesizer in the sense of how you iterate to the search tree. So a search space, that you have a search space, and how do you go now to the search space? At the possible decisions that you make.
It's an optimization problem. You have your search space, and you have to traverse to your all search space and find the best or solution, or one close to best solution when you have less compute power. It's just optimization problem. And what we have in our brain are neurons, which are combined in a way that we heuristically can get very fast to solutions in the search space. When we train a lot of thinking about chess or some other strategy games, we just have been wired in a way that we can solve this optimization problem very fast. And then we can say, okay, here in this situation, following moves gives following will happen. And it's optimization problem. And now when you are have chests, and Martin, Kasparov, remember how many steps did Kasparov on average rethink before he made a move? Martin, do you know? It was 12.
No, I don't know.
Yeah, 12. 12. He could calculate in his head 12 his huge graph and 12 moves ahead. And when we have computers, we can even go deeper. And it is this hierarchical forward planning or hierarchical search problem. But the second thing what you mentioned is that to start synthesizing. And here we go from hierarchical forward planning over to something completely new. And it is like I have different graphs that I optimize, but then I start jumping between these graphs. I have a graph maybe about chess, like it's played in medieval times. I have a chess book from Garry Kasparov, or famous Estonian chess player Paul Keres, and then I start combining it. And then we go over to something that is level 2 thinking. So you don't have just this hierarchical search or hierarchical optimization, but you start combining search results from different graphs and linking them together. And this is what is creatio. This is what is intelligence. This is how you create new ideas. You have these different graphs and you start combining them and combining the dots. And this is the real intelligence. And for LLMs, of course, you have maybe recognized now that they don't do it, but we call real intelligence, that you take these different graphs and you can combine graphs. This is what is real creation of new ideas, creation of new concepts, or new solutions. This is intelligence, Martin.
And you're calling it level 2 thinking. So level 2 thinking means we have the different scenarios, and then we start to combine these different scenarios. So it's not only that we have a big hierarchical search space that we are traversing through, or it could be the traveling salesman or some other optimizations or random optimizations there. So, but that we have multiple graphs, multiple search spaces, like you said, okay, scenario 1, scenario 2, scenario 3, and now we start to combine them. We start to look on scenario 1 search space, scenario 2 search space, scenario 3 search space. We start to combine and look which gives me the best option. So, and this is now where we are getting to the intellect. So that is intellect. So if you're speaking artificial child intelligence, intellect. So that's how we are getting now. It's a decision space, but not only one hierarchical decision space, but starting to combining. And through this combining synthesis, you're creating a new information. Like AlphaGo, the deep mind started to create new moves. All the chess players start to create new moves that no one has played before. And okay, this is an intellect that's not repeating like LLMs. LLMs are repeating statistically the words which someone else has then produced. But now in AGI, in artificial child intelligence, so it starts to create new information which has not yet been created just by synthesizing it. So
yes, you optimize different graphs and you start synthesizing search results from different graphs. And this is how AlphaGo works. Now you have the big question, Martin. These algorithms are there. We have demonstrated it in AlphaGo that these algorithms work and they work very well. But somehow everything is pushed towards LLMs. Okay, we come to this topic later in speech, Martin. But what I wanted to emphasize here is that we have algorithms, we have results which show how you can do this optimization. And now we have even results how you can combine LLMs, very small LLMs, with Monte Carlo search or graph optimization, and you get better solutions for mathematical problems, then you have it.
Okay, but let me jump now in on the. Okay, let's take a chess. Now the chess, there are rules. There are certain rules that can be done, but these rules they are limited. Now, let's go now to the world of the humans. We have so much information. There are so many classifications. There, okay, in the city there are the streets, there are trees, the birds, there are flowers. Like there's so much information now. And if you're getting a chess play, there is like this information is rather limited. So like the rules are codified, and these codified rules we can call it a knowledge graph of a chess, or knowledge graph of the AlphaGo, the Go game. So practically we have a knowledge graph. But now, if you get to the artificial child intelligence, then this intelligence has to understand as well this knowledge graph that is around us. He has to understand it, and not only like in an example of LLM, then create the most probably next sequence of the words without understanding it, but to understand to have the knowledge graph, the classified information, semantical trees. I don't know, Tarmo. Maybe you can explain it better. The knowledge graph that is required.
Knowledge graph. Take for example human hand. We have 5 fingers. Each finger has following joints. This is how knowledge graph is constructed. And if you have knowledge graph, it gives you real world constraints. It tells you how real world works. Auto has 4 wheels, or auto
The car has 4 wheels.
The car has 4 wheels. It has following parts. It consists of it's built out from following parts. We have a knowledge graph of a car, or a knowledge graph of human anatomy, etc. And when we have knowledge graph, it gives us the same, like it said Martin, in chess or AlphaGo, real world constraints. It tells us real world works like this. And again, this technology of knowledge graphs, if you do a search in Google or Bing, it's behind knowledge graph technology is used massively. But do we use it now in so-called LLM-based AI? No, we don't use it. There are a number of research papers which show that LLM performance goes up massively if knowledge graph information is involved in LLM answer generation. And it's like you don't hear about it. And when you use then AGI or AI models now, if you generate pictures, for example, you generate pictures where you can have 4 fingers or 6 fingers, or and this
3 eyes.
3 eyes. They don't even know it's wrong. They don't recognize it because there is a missing link to real world. And this real world is what we have in knowledge graphs. We have all real world concepts in knowledge graphs and how they are related to each other.
So it's a codified information that is around us, the real world information. It's a codified.
Yeah, it's not virtual like you have it in chess or in AlphaGo or in
Go.
In Go. It is then more in real world. If I have bicycle has following parts, and or human, how many fingers we have, and etc. And this is knowledge that is codified in knowledge graphs. And when you now want to become an AGI, then you need not just this virtual world what you have in chess, and where you can run your optimization, or in Go and run through your huge graphs. No, you need also connection to the real world. You have to bring in knowledge graphs of existing world, Martin. And and this is the interesting thing is this technology is here. This technology is available. Same like AlphaGo demonstrated very well hierarchical forward planning and optimization of these huge graphs. The same we have knowledge graphs. This is technology which is available already like 10 years in mass production. And we have these elements, we have all these dots, what you actually need to build an AGI. But instead of building or connecting these dots, we built just bigger and bigger compute centers.
And we build bigger and bigger LLMs, and we try to find more and more data to train these LLMs, but there's a limitations because the LLMs are already trained with all data, all public data that is available. So that means some of the LLMs are like the solution in the LLM way of thinking is do the same thing, but make it even more bigger. Although now, if you're going back to the AlphaGo, okay, when did we, 2017, 2015, 2017? Yeah, soon 10 years, yeah.
Yes, and knowledge graph, very mature technology, AlphaGo optimization by Monte Carlo, very, very mature technology. It's all here. And in AlphaGo, how he can then really start already this so-called level 2 thinking, where he can see different concepts and then between different optimizations, see the links. And technologies for it are available. And what we hear everywhere is LLM and yet another LLM, and we have to build yet another compute center, and NVIDIA, or it's the best stock in the world, and soon we will have even more NVIDIA chips. And it's very, very interesting to monitor it, that it's like one part that we need to build AGI. One technology is like taken out, but this one technology cannot build AGI. And what it shows is like we push a kind of narrative, and it's the same what we have, Martin, seen in DeFi, where venture capitalists pushed the DeFi narrative and fantasies and things to regulatory how it's called, regulatory front running, and all this game what we have seen in DeFi, it is repeating now in LLMs. We push a narrative what is not bringing word to AGI, but we tell.
Okay, it adds certain value, like the DeFi is adding certain value. Okay, but the DeFi had the limitations because very much of DeFi focused on the variable rate and the variable term. Although we know the real world is a fixed term and fixed interest. So that and then as well as some pretty many regulatory aspects, meaning that the DeFi products are doing very much pool concepts, meaning peer to pool to peer. But it's pretty much regulatory. But let me just say it like as soon as you're pooling the assets, you are fully in a different category of the regulations. Okay, there's now this just this news about the Lido, that Lido staking, that the SEC is considering Lido staking as a security. Okay, so why? Because the assets are pooled and the return is then paid on the pooled assets. So that means there were several concepts, and there were other concepts we have done earlier Twitter spaces. We have analyzed this pretty much, but DeFi was they had pretty many limitations. So that means there was a lot of success in DeFi, but by defining the ecosystems which had these limitations in the beginning, then probably the outcome, the impact of DeFi was a little bit more limited than it would have been without these limitations, like in a narrative definitions. And now the same, Tarmo, what you're saying, the same is in an LLM or in this AI.
Yes. Instead of pushing that we take LLMs, knowledge graphs, Monte Carlo, and optimization, and we bring it together, instead it's like all in for LLMs.
There is an overemphasizing on LLMs, overemphasizing on NVIDIA graphic cards, or the graphic processing units, GPUs, so because they're needed for the processing. But let's say it in this way, like if you think that your only solution is to scale up, then maybe your algorithm is wrong. And that's what the AGI is then saying, that the same results can be achieved with much less computing power, with much less. Because, okay, let's repeat, what is then the AGI? In AGI, it's all this, we need a level 2 thinking. That means we have hierarchical forward planning. We have the search space. Okay, there's a search problem, decision tree. How do we iterate the search space? Search space meaning all possible combinations. How we iterate the search space. The second is a knowledge graph. So like does a human have on one hand 4 fingers, or 6 fingers, or 7 fingers, or 5 fingers? So all this knowledge graph has to be codified. And now the search space is then interact like cross-merge with the knowledge graph. Let's make an example of a chess play. Okay, chess rules are very simple. Okay, but even with these highly simple rules are getting very complex game. Now in a Go is even more. The rules are even simpler, but the game is even more complex. So, but now if you're taking the world of humans, the real world, the world where we are living, there is so many these rules, so many knowledges, so many concepts, and these knowledge graphs they have to be defined. These knowledge graphs they have to be created. And now with these knowledge graphs, and you will have now this hierarchical forward planning. Okay, you have this search like decision tree. Okay, so. And then the next step what we are speaking is that not you that you have just one like a hierarchical and going like one way, but you start to try as well the different scenarios. You start to combine. You start to find similar patterns. You start to combine, and which ends up in the synthesis of new information. So, which is then the actual intelligence, not repeating what was there already, not iterating decision space what someone else has defined, but by synthesizing the new information. So, and then we're getting to the AGI. So we have knowledge graph. We need the search tree, the decision space search tree, and we need this level 2 thinking, combining different search trees, like the findings from different search trees, combining them together and synthesizing the new outcomes. And then we are getting to the AGI. Now we are not getting to the AGI by building bigger LLMs. Okay, like Tarmo is saying, the LLMs are on the limit already. Like all public data is fed into the LLMs. Okay, the NVIDIA graphic cards, they're getting bigger, but the LLM as an algorithm will not bring us to the AGI. So the AGI needs different technologies, and Tarmo, your point is these technologies are there already.
But these technologies are, knowledge graph is in mass adoption 10 years. Monte Carlo based optimization for Alpha or Go, what AlphaGo did too, is over 5 or 7 years already.
2017.
Yeah. Production style solutions, very, very heavy load solutions are here. And instead that we take now LLMs, we combine it with knowledge graphs, we combine it with hierarchical planning, we combine it with Monte Carlo optimizations. Instead of we invest now all into NVIDIA and build bigger and bigger LLMs. And it reminds me very much what I just mentioned, Martin, in DeFi, how all industry was led into a kind of way which was regulatorily uncompliant and which will lead to the disappearance of most DeFi companies. Sorry to say, most of DeFi companies are regulatory incompliant. As soon as you have pooling, it is over. You need a license in every country, plus for every product you have, you need a license again in every country. And this was pushed by venture capitalists. They pushed all the DeFi industry into kind of stopping road. And we see some very, very interesting. We see actually same behavior here, like venture capitalists push the industry into a path where it's dead end path, the same like we saw in DeFi, Martin.
Okay, but let's say this path, it gives certain advantages. Now let's look on which economical sectors. We have analyzed this in a previous X spaces, Twitter spaces. Which economical sector have the biggest advantage from this, from the LLM technologies?
Yes,
these are the corporations. These are the back offices. Now let's take small medium enterprises. Now small medium enterprises, they are dealing with a very interactive with their clients. It's a level 2 thinking. It's not repetition. Okay, maybe in some places you have repetition, but okay, then you have back office in a small medium enterprises. But if you take in a corporation, yeah, huge back offices, it's operationalization, the repeatable processes. And
corporation is level 1 thinking. As soon as you start doing level 2 thinking, you will be punished. And if you repeat, you will be punished even more.
So yes, because cooperation by definition is operationalization, and operationalization means repeating the procedure. Everything is documented. You just follow the procedure. You repeat the procedure. Now, this kind of work, the back office work, of course, they can be automated. So that means the LLMs will have a massive benefits for the back offices by the back office automatization. Now, but let's look now. Real economy, we have 20% are corporations and 80% are small, medium enterprise. Now, small, medium enterprises, they are very agile. There's very much client interaction. In the client interaction, you cannot follow an operational procedure. Your client will find another service provider.
Without operational procedures.
Yeah, who is thinking in the problem solving? So in the SMEs, about the problem solving. So we need to solve the problem, and this requires the level 2 thinking. So SMEs have to do the level 2 thinking, like to synthesize the client the problems, to find solutions, creativity, which is and the intellect. So that means on the small, medium enterprises, we need intellect thinking as opposed now to the corporations and back offices where we have like everything nicely documented. Even with IT systems, everything documented, and then we are just replaceable back offices. Like
And Martin, what you are saying is that LLM technology is pushed currently to operationalize or to improve performance of corporates and not small and medium enterprises where you have level 2 thinking. It is for companies where you have level 1 thinking mainly. These are all our corporates, and this is why LLM technology is pushed. And it's not interest actually, if you look, follow the money to build up AGI, like what we mentioned, that you combine now small LLMs with hierarchical planning, with Monte Carlo, with knowledge graphs. It looks like not to be the interest. Instead of the interest is to help corporates to automatize their level 1 thinking employees, or to get rid of level 1 thinking employees. Let's say it like this.
Yeah, in the corporations, the level 2 thinking is okay. Everyone who has worked at corporations, yeah, a little deja vu. So level 2 thinking is a little bit limited. So it's entitled to a certain time moments in a certain meetings. So it's a very limited. Or it's entitled to a little bit bigger position to higher up in the hierarchies. Level 2 thinking. So corporations are very much level 1 now. By implementing the LLMs in the corporations, okay, we are just simplifying the corporations. We are reducing, okay, how are corporations are producing money? There are two ways. Okay, raise the price. Okay, raise the price for the people, or reduce the cost now. By introducing the LLMs in the back offices, we will just lay off people. And the corporations will lay off people, and which is automatically increasing the corporation's profit margin. So that means for the corporations, this technology is very perfect. They will again increase their profitability margin without like a real innovation. It's innovation, it's an operational innovation, where it just cut out the parts of operations and you replace this with the LLMs. Now, but we're speaking here of 20% of the economy, okay? We're speaking here of the corporations now. But then there's a rest of the economy, small, medium enterprises, okay, like a German word, Handwerker, let's say some specialist. Just imagine you are calling some specialist to do something in your kitchen. So now just imagine that if he would follow now level 1 thinking, some operational procedure, probably you're just telling him, okay, thank you, I don't have time, please walk away. You cannot do this. You cannot do it. So that means small, medium enterprises, they have to work in a level 2 thinking now. But the LLMs is not for the small, medium enterprises. They are then for the corporations, the back offices, and the corporations, without innovating new products, now can increase the profitability margin again.
Martin, you said no, very important. Without innovating new products, they can increase the profit margin. Without innovation, and if you go over to AGI or level 2 thinking, then you start doing innovation. You start doing creation.
Bingo.
Creating something new.
Because AGI, by definition, means creation. It means synthesizes. Let's repeat these 3 parts. We have a knowledge part, we have this hierarchical forward planning, And we have the synthesizers, the level 2 thinking. We have synthesizers of different search trees. We have the synthesizers creating the new information. So AGI per definition, artificial general intellect will per definition synthesize new approaches, meaning new innovations. So, but by introducing the LLMs, we are not synthesizing new information. Okay, we are just okay. We are producing a new sequence of the words, most probably sequence of the words for the given prompt, but the corporations will reduce their operating costs and they will increase their profit margins, but not
And
increase the innovation.
only operational innovation, no innovation in products, or no innovation like you solved a new problem, or no innovation. Yeah, this is what we have in LLMs, and what we see now, like industry is not pushing towards AGI. Industry is pushing towards operationalization of corporates. And now let's jump over to blockchain. And Martin, what you see in blockchain is we have like 20 companies who want to build AGI in Web3 and blockchain. And please comment it, Martin.
Oh, okay, let's start it this way. Like we launched the first AI, a crypto, a credit score, AI-based credit score. We are using AI models to credit score. So we launched it 2021 now. And we added as well us in the CoinGecko AI list. And I think at that time when we added us there, okay, we are by the market cap on the position 20. So, and at that time there were like 20 companies like AI in the CoinGecko. In the CoinGecko, the AI list there. Now, I think currently there are like maybe 200 or so, 10 times more. But that time, I think from this 20, maybe half or even more, they really were doing some AI. They really had some products. And these are usually predictive AI products. These were concrete use cases on the blockchain data, concrete value adding use cases. But now when this LLM wave started and all this VC push started, then we start to see all this chat GPTs or decentral AI or Deepin, and now we have as well this 20 or something projects there in this list who are then trying to create an AGI and the blockchain. Now, well, okay, let's think again. What is an AGI? AGI is a search problem to the decision tree, so we get very many decision alternatives. So which is the best decision sequence? So it's a search tree optimization problem. Then we have a level 2 thinking that we can combine different search trees, and we have a knowledge graph. So 3 components. Let's put them together. And now the question is, of course, what is the relation of this AGI then with the blockchain? Well,
Martin, there is very simple relation. In blockchain, you cannot build AGI. And this is what you see now happening. AGI is like narrative is we build AGI in blockchain where it is impossible. And outside of blockchain, where we could build AGI, all the resources are pushed towards LLMs where you cannot build AGI. And so it's like a situation where all the technology is led in a way that you cannot build AGI. Martin.
Yeah, because AGI per definition, it means innovation, it means synthesizes. It means that innovation speed will accelerate. Now, by creating the LLMs are not synthesizing the new information, so LLMs are only repeating the most probable sequence of the words based on all publicly available data. And in autoregression mode, they are just producing these words without understanding what is happening. So, okay, we spoke a lot about LLMs, but now let's look at the Web3 and AGI. Okay, Tarmo said it very nicely. Web3 has no relation to the AGI. So that means as well these 20-something projects who are there in the CoinGecko AI list, it's a gambling. So if you're investing in one of these projects, it's a gambling. So maybe they're going up, but probably by given time, and the time is a little bit longer, these projects are definitely going down because there are no products, especially in the blockchain. Now the same is as well then with the LLMs. like all these LLM interfaces, ChatGPT interfaces, or that other OpenAI emulators on the blockchain. Probably the same is happening because you don't need a blockchain for this to create a little wrapper around the OpenAI. So, and what will be the use case now, blockchain and AI? It's the same use case as it was like 2 years ago when we were in the position 20 in the CoinGecko AI list. It's a predictive AI. It's predicting things based on the AI models. That's a use case in a Web3. So we have a lot of blockchain data. Okay, making a little jump to the chain-aware. In the chain-aware, we predict rug pulls before they happen. We predict fraud addresses before we are transacting with them. We are using credit scoring models. We are using ad tech. We are predicting the intentions of the users, whether the users doing as a next, whether the next probable actions of the users. And so we are predicting, based on the blockchain data, we are predicting the actions. So it's a predictive AI. And actually, I think two Twitter spaces ago, it means then two block times Twitter spaces ago, it means then 4 weeks ago, we were analyzing this. There was this one blog article about Vitalik Buterin about AI and the blockchain, and actually, we fully agree with what he's saying. So, of course, he's packaging it, of course, very nicely politically correctly. So, what he's saying, de facto, what he's saying is a predictive AI that's in the blockchain. So, generative AI has no space on the blockchain, and okay, AGI then in the future, anyhow, it's not related to the blockchain. Now, blockchain is a lot of data, and all this data can be analyzed. In all this data is so many patterns, and the AI algorithms are perfect to recognize these patterns and to predict the things. So this is what on the blockchain, but now the LLMs and ChatGPTs and and AGIs on the blockchain. This is more esoterical topic. Yeah.
Martin, we have mentioned now in this discussion now very key issues and what happens in industry, and starting with what is LLM and how to build up AGI, and what are elements, that all elements to create AGI are available. All you need is connected dots, but somehow there is no interest to connect these dots. Technologies to build AGI are here. They are in very high scale production. These technologies are mature, but we don't want to connect these dots. This is what I see currently in industry, and instead of it, what I see is also there is a kind of next misconceptions from our famous venture capitalists that let's build now AGI in blockchain. Again, this is not working.
Next narrative. So they
The
create a
next
narrative.
non-working. First they had DeFi non-working, regulatory, non-compliant. Now they want to build AGI in blockchain and not do it outside where you have all the dots where you just have to connect them. No, we don't want to do it. Let's do it in blockchain. And it's very interesting. And when I hear that AGI is coming, my impression is we don't want that AGI is coming. We don't want this innovation, but AGI will bring with us.
AGI means massive innovation. And
Yes.
one thing to understand as well, there will be not one AGI. There will be multiple AGIs because let's think about chess. Let's think about AlphaGo. Okay, that's what the DeepMind created the Go game, the AlphaGo. So which was then better than the Go World Masters? So there will be specialized AGIs. There will be specialized AGIs for one topic or on the other topic, on the third topic, because the knowledge graphs, what the humans know alone, they are so big, they are so huge. So and there will be not this everything overwhelming like an AGI. Like in a chess, there's a specialized there's a specialized AlphaGo, because the knowledge graphs, they will set the limits. They will
Yes.
set the limits,
Very
and
good point.
and we are getting a lot of these specialized AGIs which are then synthesizing new information. They're helping you to think, to synthesize new information. It's not like we have the big AGI, the singularity now, and which is then getting all the information, and based on this all information, how is then deciding something that is then the best for that search algorithm.
And Martin, when we talked, and it's like my what I now learn from this discussion is like we have all these technologies that are needed to create AGI, and these technologies are here. We don't need I don't know 2000 billion parameters LLMs. 8 billion parameters is enough. We have all search algorithms. We have all knowledge graphs in place. We have algorithms for traversal of graphs. Everything is in place. Just we don't want to combine it. And why we don't want to combine is probably we are afraid of innovation.
Massive innovation that this will cause. Because if this innovation happens, let's make one example. If you take the Dow Jones from 1930, if we look on the companies which were listed on the Dow Jones index in 1930, and we look on the now companies which are listed now in the Dow Jones index, there's only one of them. There's a General Electric. That's the only one who was then and who is now. So 90 years later. So that means if you have this massive wave of innovation, okay, we're not speaking of AGI in the sense of singularity, like now there's one big AGI now. There's a lot of specialized AGIs and probably specialized AGIs.
Level 2 thinking, creatio, doing new things, creating something new. This is what AGI will do. Martin, sorry.
Yes. So specialized level 2 APIs, AGIs, which will create a massive innovation in the specialized domains where this AGI is created. Now, and then the impact will be the same on these corporations as it is, as we see now from 1930 till 2024, the same that the power balance will change. That means the existing.
Yeah. And Martin, when I continue here, what we have often is we tell to people, you will lose your job when AGI is coming. It's not people who lose their job. It is existing corporates who will disappear because there comes such an innovation wave through level 2 thinking, where you start combining different concepts, that existing corporates will disappear. Martin.
And they will be replaced then with the new corporations. Like all these current corporations, they had a lot of level 2 thinking when they were created, when they scaled up, like 40 years ago, or some a little bit longer. But corporations, by definition, are operationalizing the processes, meaning they're becoming as well alive, but inflexible. So that means, okay, the corporations are not creating innovation at the moment. It's the small, medium enterprises creating innovations. Corporations are then buying in, taking over the small, medium enterprises to acquire the innovation. But yeah, the AGI will enable innovation, not in a sense of singularity, but in a sense of specialized AGIs, like a domain-specific AGIs. Yeah, okay. But I think we have 60 minutes now fulfilled. Let's trace it back to the Web3. Okay, let's summarize on the Web3. So we looked on the LLMs. Okay, we say it, and we said it before, LLM and Web3. You don't need a Web3 for the LLMs. Okay, then AGI and the Web3 is the same. You don't need a Web3 for the AGI. So, of course, there's a lot of projects who are pushing this chat tools or whatever the AGIs. Do your own research. Okay, let's say it this way. But the Web3 data, because it's especially if it's a proof of work data, meaning the transaction cost, the transaction cost, real transaction cost, like on the Ethereum, it has a very high predictability power. It gives you very high accuracy in your prediction algorithms. And okay, and that's what we're doing in a chain where we are predicting the intentions of the users in the next actions. We're predicting the fraud happening or not happening. We're predicting rug pulls happening or not happening. We're using the prediction algorithms in a credit score. So that means these algorithms, this will be beautiful. This will be beautiful AI algorithms on the blockchain. But these two other use cases, we think rather it's like a narrative, like a little narrative for some VCs to make a little bit more money, for other VCs then a little bit less money. Yeah, okay. Tarmo, what would you say?
Yes, fully agreed. And just to repeat, technologies to create AGI are here. We just have to connect the dots. We have to connect LLM with knowledge graphs, with hierarchical forward planning, and with search algorithms. It's all here. Just connect the dots.
Okay, then okay, let's start to close here then. We have 65 minutes now. So that means we have Twitter Spaces every 2 weeks. So these are about AI and Web3. Now today we decided to dive in a little bit on AGI because there's so many discussions about AGI. So, but usually we're speaking about the concrete AI use cases in Web3. So just look on the chain alert on the Twitter channel, just scroll a little bit down and you see every 2 weeks we have a X space. 1 week ago, we were speaking about the calls, how the AI-based AI Web3 marketing will replace the calls. Okay, it was a very popular one. Then 4 weeks ago, we analyzed this the blog article that Vitalik was writing. Vitalik about AI use cases. Of course, Vitalik wrote it the politically correct way, but okay, we summarize it here in this Twitter space. So we are very interesting AI and Web3 intersections topics, and every 2 weeks we are speaking on this. And next one will be again in 2 weeks. So, okay then. Then let's finish then the topic today then. So thank you all for the listeners and who are listening later in this topic too. So if you like it, please share it. So, and yeah, thank you a lot. Bye.
Thank you. Bye.